In this lesson, we're going to be solving this problem. This problem is under projectiles. So the problem reads as follows. Calculate the initial velocity required to find the projectile at an angle of 50 degrees so that it undergoes a maximum horizontal displacement of 650 meters. Here we're given the angle. Here it's the angle. And also we're given the horizontal displacement, which is the horizontal distance. Let me draw this structure to illustrate more. The structure, it is like this. Draw like this. And this, yes, the projectile goes like this and to fall this side. This point, it's a maximum. Here, it's a starting point and the end point here. We'll represent this point, the initial point, by A, and the maximum here would say it's B, and here we say it's C. So from here to that side, the velocity is initially, that's what we're looking for. Then this projectile made an angle of 50 degrees. Then they said here the distance to here, it is 650, of which means it is SAC is equal to 650 meters. Then so here they are looking for an initial velocity. So you must bear in mind that here the final velocity here at point B, it is final velocity is 0. Then when you are from A goes here to B, the G is negative. Then here we have the horizontal component here, the speed for horizontal component and the speed for a vertical component. We'll represent the horizontal component velocity by hc is equal to this initial vc, then horizontal, it is a cos, then here the angle, it's 50 degrees. Then this vertical velocity, it's gonna be vc. We'll represent it by vc. Then you say vc is equal to initial velocity, this one. Then because it's a vertical here component, it's gonna be sine 50 degrees like this. Then here, because we are given this as 650, that means we must use the equation of motion that is used to find that 650 here. That equation of motion that is used here to find that distance here, it is a distance is equal to velocity times time plus half g t squared. Since here was talking about the horizontal, that means g is 0 because we are talking about the horizontal, of which make the whole of this term to be equal to 0. That means we are left with s is equal to a velocity times time. This s is for this distance. Then we'll say SAC, distance from here to here, is equal to then the velocity here. Then the time is for from A goes all that way to pass B to fall at C. That means the time taken from A to C means it's AC also. We do have this. Let's rearrange this thing. It's a velocity times a time take from A to C is equal to this, of which is this 650. Then from here, let us calculate time. The equation of motion to find time, it is nothing but if you use this equation of motion, which say a final velocity is equal a initial velocity a plus gt. So since here we're looking for the time it take from A this to B, we're gonna use the g as a negative here. Then here the final velocity here, it is 0. Then here the initial, will use the vertical component, of which it is this one. Then let us substitute. Here it's 0 is equal to a vertical component. Here it is. Then write v initial sine 50 degrees plus, then we put g as negative because it going up, it opposes the gravity, it is negative 9.81. then this time is for A, B, not A to C, it's for A, B. Then to rearrange this, it's gonna give A, B is equal to V initial sine 50 degrees, this is degrees, divide by 9.81. This, it goes further to give 0.0781 V initial, like this. This is the velocity that we're looking for, this one. Then all this is this time it take from A to B, not A to C. Now we have to find this time it take, this one, A to C. So to find the time it take from A to C, because now the time we got, it is from here to B. So to find the time it take all down to here, that means you times this by 2. That means the time it take from A to B, it's the same the time it take from B to C. So to find the time it take from A to C, we have to times by 2 the time it take from A to B. Equal to the time it take from A to C is equal to 2 times the time it take from A to B. Then you substitute here 2 times here the time it take from A to B, it is 0.0781 initial velocity. That it's gonna give you 0.156 initial velocity. It's a velocity. Then from here you've got the time take from A to C. We go back here into our formula. This one, U times the time it take from A to C is equal to 650. So the time it take from A to C here it is. Then this, because this is a horizontal, this we took it from the horizontal velocity, this one. It's from the horizontal. That means this U here, we will use the horizontal component, this one. Then let's use it here. The horizontal component, it is initial velocity times cos 50 degrees. Then times the time it take from A to C, it is this one. It is 0.156 initial velocity is equal to 650. Then here we've got a common here. So by multiplying here, it's gonna be 0.1002 V initial squared, like this, times this and this, give this. Then this times also, this times also with this, so it's gonna give this, then equal to 650. Then from here we make this V initial a subject of the formula is equal to 650 divided by this 0.1002. Then from here get 6487.03. Let's write it properly. It is V squared initial is equal to 6487.03. this. Then let us remove this squared. Then we'll put the square root both sides. It means, say, to remove that exponent 2 on top of this V initially. Here will be left with V initially alone. It's equal to this. This is gonna give you a velocity to be 80.54 meter per second. That's the initial velocity that this problem statement is looking for. So we found the velocity that we're looking for here. That velocity, it is 80.54 meter per second.